morning, students. I am Santhan, working as a physics faculty in Target English Medium School. Okay, so today, before going to discuss the next concept in the heat chapter, one small mistake was done by me in the previous video. That is, okay, so in the heading of latent heat of melting, along with that one I wrote or fusion, but generally fusion is nothing but freezing. Okay, so melting and freezing both are different. Melting is solid to liquid, freezing is liquid to solid. That's why when you can write in the running notebook during that concept, you can put the which heading means only latent heat of melting only. That is only the small correction. Now, okay, in the melting concept, okay, so we discussed some more, okay, extra information. This information is useful to you for the competitive examination side like APRJC and Polytechnic also. So what is that one means? Okay, during the melting, which observations we are observed? Okay, we made the two observations. One is temperature is constant, and the second one is volume is decreases in case of which one? Melting of ice, because of water has anomalous expansion. That due to that special capacity, it will be behaves like that one is nothing but volume is decreases instead of increases. Okay, but one more thing is also there here. What is that one means? If the pressure is increases, what happened? What about the melting point? Is nothing but simply what is the relation between pressure and the melting point? That is simply we are considering that effects of pressure. Effects of pressure on melting. So this is the concept. Actually, okay, in the intermediate level means +1, +2 standard level, mostly in the +1 thermodynamic chapter is there. Okay, so based on the thermodynamic concept, Clausius and Clausius and Clapeyron, they give a relation between, okay, pressure and melting. Means if the pressure is increases, what happened? Water in the melting of the substances. So what is that equation? Means dP by dt is equals to L by T of V2 minus V1. Okay, this is the formula. This formula is formed by which one? Clausius and Clapeyron. The scientists are combined together. Okay, so they give a relation between the pressure and the melting. With help of this one, we can understanding that. So how the pressure is affected on the melting. So dP by dt is nothing but the changing of the pressure, okay, with respect to the melting or freezing point. That is equals to L is nothing but latent heat. T is the temperature, means melting point. Okay, so V2 minus V1 is nothing but here. V1 is the volume of the solid and V2 is the volume of the liquid. Because of our concept, what is that one? Melting. Melting is nothing but the process of, the process of changing solid state into the liquid state. That's why V1 is represented the volume of the solid and V2 is represented the volume of the liquid. In this one, we are observing that, but here listen very carefully. So what these scientists are find out that one means, okay, so in the nature, most of the substances, during the melting, what will be happen means their temperature is nothing but they start the contraction. Means we know that according to thermal properties of matter, if any substance is absorb the heat energy, it starts the expansion. If any body is loses the heat energy, it will be start the contraction. but most of the substance will be behaves like this one. But okay, in case of few substances like iron, ice, antimony substances, okay, they will be show some special behavior. Okay, so in that behavior, what we are observing means, okay, so during the melting means what will be happen? Heat energy is absorbed. Means when a solid substance is absorbed the heat energy, at that time solid phase is changes into the liquid phase. So generally, if the according to the thermal properties of matter, if a body is absorbed the heat energy, it start the expansion. That's why during the melting also must and should what will be start the expansion. But here what will be happen? It contraction instead of expansion. Okay, but in case of most of the substances, for example wax like that one, they will be show normal way. Normal way is nothing but okay during the melting. Okay, so then what will be happen? They start the expansion only, okay, in the regular mode. So in this one, but okay, in what way they are expand, we discuss that. So means they find out experimentally, okay, during the melting what will be happen means, okay, so the melting point of ice is decreases. Listen very carefully. The melting point of ice is decreases 0.0073 degrees Celsius for every increasing of 1 atmosphere or atmosphere. Every means is nothing but 1. Okay, so the melting point of ice is decreases 0.0073 degrees Celsius for every increasing of 1 atmospheric pressure. Okay, so we know that 1 atmospheric pressure means 1 into 10 power 5 Pascal in 9th standard level in the concept of, okay, so in the chapter of floating bodies I will clearly explain 1 atmospheric pressure at the normal temperature or at STP, what is the value? 1 into 10 power 5 Pascal. That's right. For every 1 into 10 power 5 Pascal is increases. Okay. So on the melting process or during the melting, what will be happen? The melting of ice, okay, temperature is decreases 0.0073. But in case of, okay, the MP means melting point of wax. It is used to make the, okay, candles like that one. That is, you know, that paraffin wax. The melting point of wax, okay, is increases 0.04 degrees Celsius. Listen, okay. So the melting point of wax is increases 0.04 degrees Celsius per every increasing of 1 atmosphere. Means from these two statements or from these two sentences, what we are observing that, okay, the melting point of ice is decreases for increasing of every 1 atmospheric pressure, and the melting point of wax is increases for every increasing of 1 atmospheric pressure. That's why. So already in the previous concept I says that. So generally, okay, 1 gram of ice at 0 degree Celsius, what is the volume? That one. And 1 gram of water at 0 degree Celsius, what is its volume? With help of that volume, so finally we understood that, okay, during the melting, what will be happen? Okay, the water will be start the contraction instead of expansion. That's why its volume is decreases. So now come to the next concept in this time. Already melting concept is completed. Now we are going to the another topic, that is the evaporation. So what is the evaporation? Evaporation is nothing but the process of escaping of molecules from surface of liquid is called evaporation. Listen very carefully. The process of escaping of molecules from surface of liquid is called evaporation. In another mode, evaporation is a type of vaporization. In this process, a liquid phase of a substance is changes into the gaseous phase at any temperature below the boiling point. Listen very carefully. Okay, the main definition is the process of escaping of molecules from the surface of liquid. Okay, but what is the another definition? Evaporation is a one type of vaporization. Vapor is nothing but liquid converted to the vapor state. Is nothing but simply evaporation is a type of vaporization. In this process, a liquid phase of a substance is changes into the gaseous phase at any temperature below the boiling point of that substances. That is also called evaporation. Now I will be give a small explanation about the evaporation for your understanding that. So means how we can understand or how you can understand evaporation phenomena or concept. Okay. So generally we are observing that for understanding of you, I will explain with the help of this diagram. So now we come to the point here. First of all, we can take a large beaker. The beaker is filled with water. Sorry. First of all, we can take a large beaker. The beaker is filled with some quantity of water or liquid, but mostly we are considered the water here. So generally, due to the basic ideas in the physics, we know that the atmospheric pressure is acting on the surface of the water in vertically downward. Is nothing but atmosphere is nothing but air is contained. Our earth atmosphere or our earth surface is enclosed by the air, that is called atmosphere. That's why atmospheric pressure is nothing but what is the air present in the earth atmosphere? That air is exerted some pressure on the surface of the water in the beaker in vertically downward. These arrow marks are represented the atmospheric pressure. Okay, now come to that one. So now here we are observing that according to the chemistry or according to the thermal properties, we know that according to kinetic theory. So generally in case of liquids and gases, some intermolecular space is there between the molecules or atoms. That's why here in case of this water chamber, we are considered the circles are represented the water molecules. So between the every two water molecules, what is there? Some intermolecular space is there. For understanding of you, I will take some large, but actually it is very very small in nanometers only. Anyway, so the space is there means between the every two particles or two molecules, water molecules, what is there? Either in vertical mode or horizontal mode, must ensure some small intermolecular space is there. So due to this intermolecular space, what will be happen? The water molecules will be not in stable mode. They are in the motion with a random direction. With a random direction. That's why due to the random direction, what will be happen? One water molecule and another water molecules are collision with each other. For example, okay, this molecule is going to like this one. This molecule is going to like this. Okay, this one like this one. Like any method, not only one particular way. Okay, so due to the different motion of the molecules, okay, or due to the random directions, what will be random motion? What will be happen? Okay, so one molecule and another molecules are continuously collision or collide with each other. Due to the collide, they transfer the energy to each other. Listen very carefully. Okay, so in a water molecules, some intermolecular space is there. Due to that space only, the molecules are in random motion. Means they move with a different direction. Due to the moving of different direction, okay, most of the cases, okay, one molecule and another molecule, they collide with each other. Okay, so when they are collision with each other, what will be happen? They transfer the heat energy because of during the collision, heat energy will be released. That's why here also, when the water molecules are collide, they transfer the heat energy or energy to each other. At the same way, so generally what will be happen means, okay, convection is happens in the liquids, okay, and gases. So most of the cases means in the fluids. So here some of the releasing of excess energy due to the collision, that energy will be moved to vertically upward by the convection mode. Listen very carefully. When the water molecules are due to the random motion, they collide. If they collide, due to the collide, they transfer the heat energy to each other, and some part of the heat energy by the convection mode, it will be moved to vertically upward. That's why the water particles are molecules which are present near the surface. These all the particles are absorb the more heat energy. Okay, here also they also collide. Okay, but they also transfer the energy. But when compared to the lower particles or lower molecules, these particles will be getting more energy because of due to the collision, they absorb, okay, transfer some energy. Along with the transfer of energy, some energy will be coming from the lower molecules by the convection mode. That's why the energy will be, okay, the energy of the water molecules near the surface is more than the lower one. So that's why when this energy will be increases, then what will be happen? With help of that excess energy, so the water molecules near the surface will be overcome the atmospheric pressure. Okay, and it will be escape and enter into the surrounding air as a gas. Listen very carefully. So water molecules, between the water molecules, what is there? Some space is there, that is called intermolecular space. Okay, so due to the intermolecular space, water molecules are in random motion. So means is moving is nothing but they are moving into the different direction. Due to the random motion, okay, water molecules are collide with each other. They transfer the heat energy to each other. Okay, but some part of the heat energy will be goes to the upper phases. Okay, in the same vessel by the convection mode. But in this one, okay, so the water particles which are present near the surface, they are also collision and transfer the heat energy to each other. Along with this one, they grab or receives some extra heat energy coming from the other molecules by the convection mode. Okay, due to collision. That's why the water molecules will be get sufficient energy to overcome the atmospheric pressure. Okay, then they will be, okay, escape and enter into the surrounding, okay, air as a gas. This is the main reason for the evaporation process. Initially, all the molecules are in which state? Liquid state. Okay, so by the collision of each particles, what will be happen? So the surface of the molecules is absorbed more heat energy, then they overcome the atmospheric pressure and convert it into the gas, and it will be escaped from the beaker. That's why evaporation is nothing but the process of escaping of molecules from the surface. That's why from the surface of the molecules only they will be escaped. After this one, what is the surface? Next row. Next, second case, these molecules are evaporated. Next, this. That's why. So evaporation is a which type of process? It is a cooling process. And also it is a endothermic process. Listen very carefully. Evaporation is the first one. It is a cooling process. And second one, it is a endothermic process also. So how we can say evaporation is a cooling process? Means in this case, in this example, after the collision, the molecules are transfer the energy to each other. And after that, some energy will be move to the vertically upward. Means finally, what will be happen? They loses the energy. Generally, we know that when the two particles are collision with each other, so they loses the energy. That's why, but they transfer the energy. But during the transfer of energy, what will be happen? They loses the energy. When they loses the energy, what will be happen? Temperature is decreases. That's why the temperature of the evaporated liquid or vaporized liquid is gradually decreases due to the losses of heat energy with each other. That's why evaporation is a cooling process. Based on this one, they are asking one question to us. When a spirit containing alcohol will pour on our skin, we feel cool. What is the reason? Listen very carefully. So a spirit is contained with the alcohol is spill or we can pour on our skin, you feel cool. What is the reason? Means when the liquid will be fall on our skin, what will happen? The liquid, actually the spirit is contained alcohol, its boiling point is very less. That's why, or in case of maybe petrol also, when during the filling of petrol in the bike, maybe unexpectedly 2-3 drops are spill and fall on your skin, so immediately you feel some coolingness. What is the reason? Means the boiling point of petrol is lies between 15 to 20 degrees Celsius is there. So due to that one, generally the atmospheric temperature is normal one is 20 and 22 it will be 30 is there. That's why the atmospheric temperature is more than the boiling point of the which one? Petrol. Or spirit. That's why when they will be fall on our skin, then immediately the petrol particles is absorb some heat energy from our skin. Then what you feel? Means so when they absorb some heat energy, so our body will be loses a little bit of heat energy. Due to that, you feel the coolness. Next one is the endothermic process. How evaporation is a endothermic process? Endothermic process is nothing but so the substance will be absorb some heat energy during conversion of the state. That is so endothermic is nothing but it absorbs the heat energy during the process. It absorbs some heat energy, that is called endothermic process. How evaporation is an endothermic process? Here we are observing that the surface of the molecules is absorbed some excess heat energy from the lower molecules or not. That's why evaporation is a cooling process and also it is a endothermic process. By the cooling process concept, we can say that the temperature of the evaporated or vaporized liquid is decreases by losing the heat energy. And it is endothermic, means during the evaporation, the surface of the molecules is absorbed some heat energy. That's why it is an endothermic process. So now once again listen. Evaporation is nothing but the process of escaping of molecules from the surface of liquid is called evaporation. Evaporation takes place at any temperature below the boiling point. Evaporation is a cooling process and also it is a endothermic process. Next, come to that one. This evaporation process is depend on some factors in the nature. What are the factors are affect the evaporation or rate of evaporation? That's why we come to the point. The rate of evaporation. The rate of evaporation is depend on the okay following factors. So listen very carefully. Okay, the rate of evaporation is depend on the following factors. How many factors are there? Means totally 5 are there, but in 10th standard we discussed okay only 4. First one is surface area. Second one is humidity. Third one is wind speed or wind velocity. Fourth one is temperature. Fifth one is pressure. So the rate of evaporation is depend on the mainly these 5 following factors: surface area, second one humidity, third one wind speed or wind velocity, fourth one temperature, and fifth one is the pressure. But in 10th standard we discuss the up to the 4. Okay, means surface area, humidity, wind speed or wind velocity and temperature. Now we discuss that. Okay, so one by one, how the rate of evaporation is depend upon the surface area, humidity, wind speed and temperature. So next our concept is explain how rate of evaporation depends on the surface area and the humidity. This question is also one of the most important question for 4 marks in public point of view or in other examinations, means in essay 1, essay 2, free fund like that one. In the chapter of heat, along with how to find specific heat of a solid experimentally. Okay, now we discuss that. So how the rate of evaporation depends on the surface area and humidity. First one we discuss that how the rate of evaporation is depend on the surface area. So for this one activity is there. So how to find evaporation is depend upon the surface area, and what is the relation between them, that is we discussed with help of this small activity. First of all we can take okay a saucer or china dish and a cup. Both are filled with same quantity of same liquid. Listen very carefully. Okay, first of all we can take a saucer or china dish and a cup. Both are filled with same nature of the liquid with the same quantity. Means same quantity of the same liquid. Means it is filled with water. Means it is also water. It is the hot tea. It is also hot tea. It is filled with spirit. It is also spirit. That is the meaning of that one. Okay, so now after that, both are kept on the table in a room or in a open place, whatever that may be. Mostly in the room, we have considered that. So first of all, we can take a saucer or china dish and a cup. Both are filled with same nature of the liquid of same quantity. Now both are placed on a table in a room. Okay, so after some time, you will become and observed. Okay, most of the liquid is disappeared in the saucer and less in the cup. Okay, that's why what you are understanding here. Okay, so means surface area is more, evaporation is also more. Surface area is less, evaporation is also less. This is the way of method to write in the examination. But okay, how the surface evaporation is depend on the surface area. Here I will explain with some example. In this one, it is the saucer where I can say here. So what I say is that okay, after some time, okay, in our experiment, what we are observing that more amount of the liquid or more quantity of the liquid is evaporated in the larger surface area is nothing but saucer or china dish, less in the cup, that is that. But how surface area is increases, rate of evaporation is also increases, means in this one the saucer or china dish have larger surface area than the cup. Cup has smaller surface area. Due to the larger surface area, what will be happen? More molecules is present near the surface. Here lesser molecules are present. In this one you are observing that 1, 2, 3, 4, 5, 6 for understanding of you. Here how many are there? 3 are there. Means for every 1 second, just you can set that. For every 1 second, here in the saucer or china dish, these 6 water molecules are evaporated. But here in case of cup, how many? Only 3. Here 3 molecules. Here 6 molecules are evaporated. That's why means each molecule, just for understanding of us, 1 ml we have considered that. That's why how much ml it is evaporated for 1 second? 6 ml here. Here only 3 ml. Are understanding or not? That's why, so means 6 ml is more than the 3 ml or not? That's why more amount of the liquid is evaporated in the saucer or china dish, but lesser in the cup. That is the main reason. So once again listen, how we can write during the examination means so after putting the surface area of heading like this one, you draw the saucer, china dish and cup diagram. First of all, we can take a saucer or china dish and a cup. Both are filled with same quantity of liquid with the same nature. Now both are placed on a table. The table is already kept in the room. After some time, that is the as you wish, 1 hour or 2 hours, most probably 5 to 7 hours we are considered. After some of the time, you will become and observe the level of the liquids in the saucer and china dish. We are observing that in the saucer more liquid will be disappeared and less liquid is disappeared in the cup. So means from this one, what you say is that surface area is more, evaporation is also more. If surface area is less, evaporation is also less. But what is the reason? That is for understanding of you, I will be explain. What is the reason? If surface area is more, more number of molecules are present near the surface area. If surface area is less in the cup, that's why only few water molecules or liquid molecules are present at that one. But according to, for understanding of you, only I will be considered these values. Means in a saucer has larger surface area than the cup. That's why if more surface area means more liquid particles are present near the surface, here less. Here for understanding of you, 6 particles, 6 water molecules are present at the surface area, here 3 are there. That's why for every 1 second, this 6 will be converted to the gaseous state. Just understanding. Here how many? 3 is there. So one water molecule has very less. But for understanding understanding of you, okay, 1 ml we have considered that. Each water molecule has 1 ml means, so for every 1 second, how much, okay, quantity of, okay, liquid is disappeared or evaporated in the chain rod is 6 ml, in the cup 3 ml. That's why, okay, evaporation is more in the saucer, less in the cup. Next one, how the evaporation is depend on the humidity. How the evaporation is depend on the humidity. So now, okay, with help of this diagram, you can easily understand, or with help of this activity, you can easily understand humidity concept. But during the examination, no need to draw this diagram. For which one? Humidity. Okay, just for understanding of you only, I draw this diagram. Okay, so what is the humidity? First of all, humidity is nothing but the amount of water molecules present in the air is called humidity. The number of water molecules are increases in the air, humidity is also increases. The number of water molecules are less per unit area or volume, humidity is also less in that area. That's why, so means the amount of water molecules present in air is called humidity. That is the statement or definition for this one. But now our concept is, what is that one? How the evaporation or how the rate of evaporation is depend on humidity factor. Okay, now come to that one. First of all, you are selected a closed room. Okay, so means it has the door commonly. Okay, so first of all, you can take a beaker. The beaker is filled with liquid of. Okay, so first of all, you can take a beaker. The beaker is filled with certain quantity or amount of liquid and placed over on a table. Then finally, this entire the apparatus is kept under a ceiling fan. Now in this one, okay. So now we can switch on the fan and close the door and we can leave from the room. After 4 or 5 hours, okay, you will become and observe the what is the level of the liquid, or okay, if you cannot observe it clearly, so with help of the measuring jar you can measure the quantity of the liquid here. So for understanding of you, I will be saying here initially. So okay, initially in the beaker just we have taken 50 ml of liquid. How much liquid we have taken initially? Okay, so initially we have taken 50 ml. That is the we have considered that. Now here we are observing that this is we have considered 50 ml of liquid we have considered. This is the V1 ml we have considered that. Now after the 4 or 5 hours we will become and observe and measure with help of the measuring jar. Okay, so we are observing that nearly 30 ml. Means what is the volume of the liquid in the beaker after 4 or 5 hours? 30 ml. Means what is the difference? Okay, so then V is equals to V of T1 means in the first time. Okay, or V is equals to V1 minus V2. That is nothing but 50 minus 30. So 20 ml means how much amount of liquid is evaporated, means 20 ml of liquid is evaporated. But here it is which type of room? It is a enclosed room. Due to that one, the evaporated liquid will be go and settled where? Inside the room only is there. Means so initially already inside the room what is present? Air is present. Okay, so already we know that air will be contain some concentration of water molecules, but now here 20 ml of water molecules is evaporated, is nothing but 20 ml of liquid is converted to the vaporized, means this vaporized water molecule will be again go under increase combined with air present in the room. Due to that, the concentration of air molecules is increases. The concentration of the water molecules in the air is increases. Okay, is nothing but indirectly. What you can say is that humidity is increases. Listen very carefully. Humidity is nothing but the amount of water molecules present in the air is called humidity. Initially, before starting this experiment, some air is present inside the room. Means air is there, means some water molecules are present in the vapor state or not. Okay, but now after completion of this experiment, initially how much ml of water or liquid is evaporated? 20 ml. This 20 ml of the water is converted to the vaporized state, and the vaporized water molecule will be mixing with again which one? Air only present in the room. Is nothing but the water molecule, means vaporized water molecule component or concentration is increases in the where? In the air. Is nothing but the amount of water molecules are increased indirectly. So means humidity is also increases. That is your answer here. Next, after this one, again we can take the another beaker. The another beaker is also filled with 50 ml, means same quantity like initial mode. And again we can do the same experiment after 5 or 6 hours, means how much time, after how much time. Okay, in the first case we are observing the process. Okay, like the same way, means in the first case after 5 hours we are observing that. Like the same way, in the second time also after the 5 hours only it will become and observed in the third kind. What is the V1 value in the second time? 50 ml. And what is the V2 value in the second time? Means most probably we can say that 50 ml. This is the V3. V3 means second case in the second beaker. That's why 50 minus 40. What is the volume? Only 10 ml. Means what is the meaning of this one? Okay, only 10 ml of water or liquid is evaporated, and at which time? Second time. So in the first time how much ml? 20 ml. In the second time how much ml? Only 10 ml. So means what I am understanding here? Okay, so means if the humidity is increases, evaporation rate is decreases, because of initially humidity is in the normal mode, we have considered that. But after completion of the first concept, 20 ml of liquid is converted to the vapor state, and concentration of the water vapor molecules increases in the air. Is nothing but humidity is increases. By increasing the humidity in the second case, same nature and same quantity of liquid we are taken, but the evaporation liquid is less. Means if the humidity is increases, evaporation is decreases. That is your understanding. But how we can write? Means simply. Okay, so first of all we can take a beaker. The beaker is filled with certain quantity of liquid and placed over a table. Now this total entire system or apparatus will be kept under a rotating ceiling fan. Now we can close the room and leave it. After 5 hours you will become and observe and measure the liquid. Measure the level of the liquid. In this one we are observing that. So and noted its value. Next we can repeat the same experiment again. By filling the another beaker with the same quantity of liquid and do the experiment. In the second time we are observing that lesser amount of liquid only is evaporated when compared to the first one. In the first one more liquid is evaporated. In the second case less liquid is evaporated. What is the reason? By the first process, so which amount of liquid is evaporated, that evaporation liquid is nothing but, so this is go and settle with or mixed with air particles. That's why humidity is increased, means the number of water vapor molecules are increases inside the room, means is nothing but humidity increases. By increasing the humidity, what will happen? Rate of evaporation will be decreases. Next, the third one is wind velocity or wind speed. Okay, so how the rate of evaporation is depend on wind velocity. What is their relation? We discussing that. So with help of one example, you can easily understand the relation between wind velocity or wind speed and evaporation. Simply in our daily life example, I will tell one thing. Okay, so just so means after washing the cloth will be contain still some tiny water droplets in it. Okay, so now here after wash the cloth, what you can do most of the cases, at the roof of the houses, some strings or ropes are there. On the ropes we can suspended or hanging, suspended the which one cloth. That's why. So these are represented the cloths are suspended freely on a string. At the top roof of the house, we are considered. So now this concept we are considered two cases. One is the windy day, and the second one is the non-windy day. So listen, so the same concept we are considered in the two ways. One is the windy days, another one is the non-windy day. Windy day is nothing but at that day air will be freely moves and fastly moves continuously from one place to another place. Non-windy day means it is the normal way. So we are observing that in case of windy day, the cloth will be get quickly dry up and compared to the non-windy day. Is it correct or not? So generally we are observing that after suspended or hanging the cloth on the rope at the roof of the house. So if that day is a windy day, so within the 1 hour the cloth will be dry up. Means the wet cloth will becomes to the dry. But at the non-windy day, what will happen? Instead of 1 hour, it will be take 1.5 hours or 2 hours also. So what is the main reason? Means so during the windy day or non-windy day, whatever the day, mostly we know that the air will be freely move in the nature from one place to another place into the random motion. So that's why if the air will be passing through from one place to another place, like this one, we can consider that from one side to another. So when the air will be moving from one place to another place, they passes through the wet cloth. When they passes through the wet cloth, in the wet cloth, what are they? Water vapor is present. Water molecules are present. That's why when the surrounding air is passing through this one, the water molecules present in the cloth will be absorbed some heat energy from the surrounding air particles when they touch to the surface of the cloth. So Allah says that evaporation is a which process? Endothermic, because of it absorbs some heat energy. That's why the water molecules present in the wet cloth which are present, that water molecules will be absorbed some extra heat, extra energy from the which one? Air particles during the touching. After that, they will be attain the sufficient energy to overcome the atmospheric pressure on that one. Then they converted into the vapor state. That's why the water molecules will be removed from the cloth. Like in the non-windy day, what will be happen? So the flow of air will be less. Means the rate of flow of air is less due to that one. The air particles. First one time the air particles will become and touch. Next, fast they are not come because of it is which day? Non-windy day. That's why. So when the air will be not fastly moving, they will be moving very slowly. So due to that reason, what you are understanding that the rate of time of touching of the air particles to the cloth at non-windy day is less. due to that one, so the water particles will be removed from the crust very slowly when compared to the non-windy day. That's why with help of this example we are understanding that at the windy day means air velocity or wind velocity is more, that's why evaporation is also more. At the non-windy day wind speed or wind velocity is less, that's why evaporation is also less. That is simply understanding. That's why, so okay, in case of bit purposes they are asking that, okay, if wind speed is increases, what happens? The evaporation. Okay, if wind speed is increases, evaporation is also increased. Wind speed is decreased, evaporation is also decreased. Based on this one, what is the example I have explained? Same thing, they are asking for 1 mark or 2 marks. Okay, what is that one means? Wet cloths will quickly dry up. Okay, what is the reason? That is one. Next, fourth one is temperature. If temperature is increases, we know that in the concept of temperature, I clearly explained to you. The temperature is increases, the kinetic energy of the molecules is also increases. When the kinetic energy is increases, their collision number of times when compared to the regular way. Because of if kinetic energy is more, speed of the particles are more. When the speed is more, when they collision with each other, they lose. Okay, they transfer the more heat energy. That's why when the temperature is increases, kinetic energy of the particles are increases. Due to that reason, during the for every collision, the molecules are transfer the more heat energy and losses the more heat energy. That's why if the more heat energy will be losses, that more losses of heat energy will be absorbed by the surface of the water molecules or surface of the molecules in the liquid in a beaker or whatever the cup we are taking that. That's why if they absorb the more heat energy, what will be happen? Quickly they can overcome the atmospheric pressure and convert into the vapor state. That's why temperature is increases, evaporation is also increases. Listen very carefully. Okay, temperature is increases, kinetic energy of molecules is also increases. When the kinetic energy is increases, okay, so the speed means initially indirectly what is happened? The velocity of the particles are increases. Okay, when the two bodies are okay, slowly they will be collision with each other. They loses the less energy. We know that if the two particles are okay, fast they come and collide, then what will be happen? More damage. More damage means okay, the energy will be transferred to each other with more weight, means more magnitude. That's why here is also by increasing the kinetic energy of the particles, due to the collisions they loses the okay more heat energy or they transfer the more heat energy, and also that heat energy will be more heat energy absorbed by the surface of the molecules and they quickly overcome the atmospheric pressure and convert it into the vapor state. That's why temperature is increases, evaporation is also increases. If temperature is decreases, kinetic energy is decreased, then automatically okay transfer of energy is also decreased, then evaporation is also decreased. So this is the main important things in this one. Okay, so if what about the pressure means, if pressure is increases, evaporation is decreases. That is okay, we discuss in the +1 +2. Okay, now in this video mainly which concept we are discussing means, once again briefly I will tell that Clausius-Clapeyron okay relation. What is the Clausius-Clapeyron relation means? So the scientist will be says that okay, so dp by dt is equals to L by T of V2 minus V1. With help of that formula, okay, we can easily understand the relation between okay pressure and melting. But the scientists are find out that okay, so most of the substances in the nature okay, if pressure is increases, melting point is also increases. But in case of fewer substances, pressure is increases, melting point is decreases. In case of ice, antimony and iron. So in case of ice, okay, they will be find out with help of the regulation concept. Okay, phenomena, regulation phenomena. With help of the regulation phenomena, we can easily find out that okay, if the pressure is increases, okay, melting point is decreases. If the pressure is decreases, melting point is again increases. Okay, that's why what they have find out means 1 gram of ice at 0 degrees Celsius. Okay, sorry, nothing but So means what is that one means for every increasing of 1 atmospheric pressure, okay, during the melting, what will happen? The melting of ice is decreases to 0.0073 degrees Celsius. Listen very carefully. The melting point of ice is decreases 0.0073 degrees Celsius for increasing of every 1 atmospheric pressure. But in case of paraffin wax, the melting point of wax is increases 0.04 degrees Celsius for increasing of every 1 atmospheric pressure. So after that, I am clearly explaining what is the evaporation. Okay, evaporation we can define in the two ways. It is a process of escaping of molecules from the surface of a liquid. Another one, evaporation is a type of vaporization. It occurs only at the surface of the liquid at any temperature below the boiling point. Evaporation is a cooling process and endothermic process also. So evaporation is mainly depend upon the how many factors? 5 factors. According to 10th standard, 4 factors are there. First one, surface area. Second one, humidity. Third one, wind speed or velocity. Fourth one is temperature. Simply I says that surface area increases, evaporation is also increases. Surface area decreases, evaporation is also decreases. Means surface area evaporation directly proportional. Next, second one is there. If humidity is increases, evaporation is decreases. If humidity is decreases, evaporation is increases. Means humidity, evaporation are inversely proportional. And third one, wind speed or velocity increases, evaporation is also increased. If wind speed or velocity decreases, evaporation is also decreases. Means these two are also indirectly proportional. And final one, temperature is increases, evaporation is also increases. If temperature is decreases, evaporation is also decreases. That's why in the 4 factors, surface area, wind velocity and temperature, if they are increasing, evaporation is also increased. If they are decreasing, evaporation is also decreased. Means with the 3 factors, evaporation is always directly proportional. But in case of humidity and evaporation, they are inversely proportional. Like in pressure is increased, evaporation is decreased.